So to analyze a parametric equation really implies to understand the equation without your calculator. And to understand the equation without your calculator, it's really going to force you to understand how does this parameter. Now, when we say parameter, we're referring to really the t-values, which as you can see here, we have a certain restriction on the t-values. But as I was saying, how does the parameter, that is the t, actually create points which turn into a graph and ultimately that we can sort of tie all together into an analysis. So that's what we're going to work on here. We're going to do this without a graphing calculator. So let's begin. Let's begin with the parameter. You see, the t-values for this problem can only be between -2 and 3. Well, that's a direct statement about the actual table of values. And what you're going to notice here is that for the first time, we can create a table of values that actually has, 3 columns. Of course, 3 columns because we now have this parameter. This parameter that starts at -2 and then is going to travel all the way to the number 3. Now, there's nothing that requires these t-values to be integers, but we typically will use integers. It makes it a little easier when it comes to plugging in. But the definite case here is that our t is from -2 to 3. Now, speaking of plugging in, when you start to do that, you can plug -2 in for t. Of course, I assume that you understand that I'm plugging it into the top equation here. So it's just going to, of course, come out to -2 squared, 4 minus 4. So it's going to come out to be 0. And I also, I also have to plug -2 in for the other t value. So that gives me a y value of -1. Okay, you can do this, right? I mean, basically you're plugging in t. I hope you notice that you're plugging it into both these places. That is, you're plugging them in both to the x and the y components of these parametric equations. All right, so we end up with 1 minus 4. We end up with -1 over 2. Yes, it's a decimal fraction. As you continue to plug in, you're going to end up with 0 minus 4. Of course, just 0. 1 minus 4. Okay, I think I've seen that number before, but this time positive 1/2. You're going to end up with 2 squared. Of course, 2 over 2 is 1. And then plug in 3. That is, you get 3 squared. And, of course, you end up with 5 and 3 over 2. Now, these green numbers, maybe better said, these green ordered pairs. Yes, that's exactly what they are. They're still just x and y values. In fact, all of them are x and y values, which can graph on the good old x and y axis. Am I going to be graphing the t value? I am not. Okay, I'm not graphing the t value. I only, you might notice, use the t value to create these ordered pairs. Now, -3, -1/2, that's probably, I guess if I'm scaling this, it's right around here. -4, 0. Wrapping around here, I have -3.5, 0, 1, and 5, 3/2. Interesting kind of set of 6 ordered pairs here, isn't it? What do I mean interesting? Well, you want to connect the dots. You want to connect the dots in the order that you plotted them. So you might notice that you started at 0, -1. By the way, we call that the initial point. I really shouldn't say by the way. That's actually part of this analysis. And then we ended at 5, 3/2, which we actually call the terminal point, which again is always part of the analysis, being able to understand what's the initial and terminal point. But the reason I bring that up is because we certainly, when we connect the dots, want to connect them in the order that we plotted them. Okay, and when you actually draw the graph in that direction, well, you get what's known as the direction of the parametric graph. These little directional arrows are also part of your analysis. Okay, now, again, interesting graph. It's actually sort of part of a sideways parabola, and parametric equations made it a little simpler to actually graph that. Of course, we could turn these parametric equations, that is the original x and y equals, we could turn them back into Cartesian by eliminating the parameter. Okay, when we turn it back into Cartesian, we're going to eliminate the parameter probably by noticing that one of the equations can be more easily solved for t. Remember how we did this in the previous module? So if I solve this equation for t, I get a little statement that t equals 2y, and that 2y is what I want to substitute in here for this other t. I'm going to pull the screen a little bit so we have some space to do that, but basically we're going to end up with 2y squared, very carefully, minus 4, which comes out to be 4y squared minus 4. Now, don't try to get too fancy. I don't need to solve that equation for y equals. It's okay that it's in x equals form, but what you definitely want to notice is that it's no longer got a t. But there's one thing we still haven't really, you might say, converted, and it would be the actual restriction on the parameter. Yeah, that restriction on the parameter is why we only ended up with part of a sideways parabola. And so when it comes to my new Cartesian equation, unless I restrict it, it's going to be referring to an entire sideways parabola. So we need to restrict it. Now, it would actually be kind of silly. We don't want to be silly, but it'd be silly if I would just say, oh, okay, it's just the same restriction. The reason that's silly is because that restriction involves a parameter, involves that third variable t. Okay, it would be equally silly if I just say, well, then I guess I'll just change that into like a y, or perhaps maybe change it into an x. Okay, that would be like saying that x, y, and t are all the same thing. You see, what you want to understand is that x and y are actually given by the original parametric equations. And so what we want to do is we want to use these parametric equations to come up with our restriction. Okay, which one should I use? Okay, it matters. You see, what you want to realize is that since this equation is in terms of y, okay, now to be in terms of y just means that x equals something y. So my equation's in terms of y. I want my restriction to be in terms of y. How do I do that? Okay, I just have to figure out what the y values are that match with the t values of -2 and 3. Wait a minute, I think I know what those y values are. I think they're right here in my table. This is the y value that goes with -2. This is the y value that goes with 3. And in case I had forgotten, yes, I could have substituted these back into the y equals equation. Of course, I'm just going to end up with the same two green numbers. Okay, so -1 to 3/2 now takes my Cartesian equation and restricts it, and officially we have eliminated that parameter. Now in a moment, you guys are going to get to do one of these analyses on your own. Remember, an analysis is when you basically think about the graph using a table, label the initial and terminal point, and then you also convert or eliminate the parameter. But something you guys are going to basically, you're going to ask is, how do I know what the restriction is that is the parameter restriction? Well, there's 3 scenarios. There's the scenario where the parameter restriction is given. Now, just so you understand, a parameter restriction that is given is like this problem when -2 less than or equal to t less than or equal to 3 was given. It was just part of the original problem. Nobody questioned it. We used it. Okay, it was given. But some parameter restrictions are going to be assumed. What do we mean a parameter or restriction is going to be assumed? Well, if you look at the example that you guys are going to do next, it doesn't look like that there's a parameter restriction, but there is. Because in a moment, you're going to be plugging numbers in here for t. And when you plug them in, you're going to square root them. Well, what kind of numbers are you allowed to square root? That's right, only numbers that are greater than or equal to 0. So this problem had an assumed restriction. If you say, yeah, so what's that going to do? Well, kids, that's going to help you when it's time to get your table of values. Okay, now your table of values, I don't want to do it for you, but has to be numbers that are greater than or equal to 0. Okay, I'm talking about the t values. So we call that an assumed restriction. There's one other scenario. There's a scenario where there's no restriction. You will see one of these near the end of this module. That means that no restriction is given, and there's no numbers that have to be assumed restricted, so you can just use any number. I mean any number from negative infinity to infinity. Okay, we can talk about that a little bit more. That's definitely an idea that takes a little time to sink in. You'll get to practice it also in your book assignment. Well, you're ready to do this next problem. And remember, you can always check the answer at the back of the packet. Okay, but don't look until you try it.